this year.
All right. So thank you, everybody. Thank you to the organizer and Bina for making this possible. And thank you to all of you for being in this room today. So yes, I run a small business registered in Canada. And today I'm going to talk about a lot of work that I'm doing with many different organizations, which are in general involved and interested in research data management. So I just want to say that to start with, that as a business running for almost 20 years, adopting well-documented standard operating procedures for quality control measurements and data management was absolutely mandatory for the successful operation of my business. So the next slide. Yes. So our goal is to automate open, reproducible, and fair science and do this in line with communities and various standards of interest to the field of bioimaging. So today I'll talk about the situation that we have in Canada in terms of data management policies and infrastructures, the tools that we have. I'll go over two use cases, one for instrument quality control measurement, and another one on data management. And at the end, I'll present the success and the challenges that we face in this context. Next slide, please. Yes. So in Canada, we have three nationwide funding agencies. One focuses on health, one is on natural sciences and engineering research, and the last one is on for social sciences and humanities. The data management policies in Canada adheres to the FAIR and CARE principles. CARE principles is something that I discovered recently. So CARE stands for Collective Benefit, Authority to Control, Responsibility, and Ethics. So in terms of the tri-agency policy requirement, the institutions have the mandate to come up with research data management strategies, as well as data management plans. And when publishing funded research, it is mandatory for the scientists to deposit into a digital repository data, but as well as any metadata and any code that directly support the conclusion of the research. So next slide, please. So to support this data management policies, the Canadian government has put together what is called the Digital Research Alliance of Canada. And as you can see, well, Canada is a fairly large country. The alliance has three components to its mission. One is to support research data management through essentially storage capacity. Secondly, it provides advanced research computational clusters, and it also wants to support open source scientific software. The various data centers are dispersed throughout the country, and all of this is connected with high-speed connections because there are about 6,000 kilometers from one coast of Canada to the other. Where most of us are based in the east, in Quebec, and we do have access to an advanced research computing cluster. It's called Beluga, the white whale. And like many other places in around the world, the Canadian infrastructure also provided us with digital repository. On the other hand, the problem with digital repositories, many of them do not handle microscope data visualization. And for that, to address this feature, a member of Canada BioImaging used a infrastructure available on the west side of the country to install a virtual machine on which he installed an instance of Homero. So now this instance of Homero is now available to all scientists in Canada. Additional support for our work is also coming from the Montreal Neurological Institute, which is an open science institution, and they want to foster also open, reproducible, and fair science. So next slide, please. Yes. So what I just want to show briefly is how we're using this infrastructure or cloud-based Omero instance for research data management purposes. Well, I'll start with the instrument quality control use case because to me, that's where research data management starts. We work very closely with Katrina Strambio de Castilla at UMass Medical School, and with her help, we installed a plugin for running Micrometa app application within our Omero instance. So this allows us to upload many Micrometa app JSON file for various microscope directly into the Omero instance. And when necessary, a copy of those JSON profile can be shared with the people in charge of the microscope. Next slide, please. So the use case here that I want to show here is one particular microscope that has been under the care of Mia Selavi for several years. And there is actually 14 years of quality control measurement on that particular microscope. And now, because we have the instance available, we've been uploading all those data set into the Omero instance. So we have the raw data, the analyzed data, and we organize this following the Quarep-Limi workgroup structure for the various components to be QC'd on a confocal microscope. We can attach to these various data set the analysis workflow as well as the analysis result and the Micrometa app profile. So that allows us to really capture the microscopy metadata fairly thoroughly. The next example I would like to present, next slide please. Thank you. Is a data management use case. That's quite a special one. We're working with a non-for-profit company called Icaros, which is the Y stands for antibody characterization through open science. This is an organization that characterizes antibodies that are used in the life sciences and neurosciences. So far, they have characterized over 100 targets, and that corresponds to about 1,000 different antibodies that they've measured by Western blotting, immunoprecipitation, and immunofluorescence. Immunofluorescence data is collected by high content screening. They want to significantly increase the amount of the number of antibodies and targets that they are characterizing. So they're piling up a lot of data. Currently, all their data is available in Zenodo, but again, data visualization is a challenge for them. So they partner with us to help them upload their data set into the Omero instance so that we can, one, improve data visualization. And this is a representation here of one particular data set. And yes, we can easily visualize the plate structure, but you'll probably notice that we're missing essentially pretty much all of the REMBI modules in terms of the recommended metadata for biological images. So we are working with them to capture all the REMBI modules. And obviously, we need to figure out a way to automate this process because of the sheer volume necessary. Next slide, please. So very briefly, for the sake of time, I'm going to go fast over this one. But again, we're partnering with Katrina Strambio de Castilla's group to automate this process. Essentially, Katrina's group has come up with an Excel spreadsheet where we can capture a lot of the REMBI module. There is an Excel helpers script that will go over the various image name and paths so that we can come up with Omero tags. And in the end, the Omero importer, along with the Micrometa app profile, is going to upload the data set and provide all the metadata necessary for for capturing those all the metadata. So next slide, please. Yes, so I'm going a lot faster than I thought. So I'm just going to end here and present our success and challenges. Perfect. So I'm pleased to see that Canada has a country-wide fair and care policies in terms of research data management. The country also provided a nice infrastructure for us to, in Canada, to adhere to their policy requirements. We've been able to come up with workflows to capture instrument quality control data, as well as workflows to capture the recommended metadata for biological images for life sciences in general. And we also have a fairly clear plan to achieve automation of open, reproducible, and fair science in general. But in terms of challenges, well, the common challenge is limited financial support. There is little support to actually implement the policies and regulate them in Canada. There's limited financial support to fully benefit the infrastructure. And there's also a limited financial support to support quality control and data management initiatives. So on that note, I'm gonna, yes, please go to the next slide. Just wanna introduce now to the team, their affiliation and the support that made all this work possible. Thank you. Arigato.